Okay, so we had that. You might have seen it another way, excuse me, where we had our a times c on the top of an x and our b value on the bottom, and that helps us kind of visualize that. Then what do we need to multiply to 40 and add to 13? And it would be 8 and 5. One bad part about that is that sometimes you get a little mental block and you just start seeing the same two numbers over and over, and we can't get past it. Whereas if we list out the factors, then there's no pressure. I'm just listing them out: 1, 42, 24, 10. Just going right down the line, making all the factors. And then I get to go back and look at which ones would add to 13. So whichever way works best for you. Excuse me. Okay, 3 terms where our a does not equal 1. Okay, so we're not going to have such a nice one. 6x squared plus 13x minus 5. Nothing in common. Okay, nothing in common here. So I can't factor anything out. We still multiply our a times our c, negative 30. And we want to find stuff that would multiply to negative 30 and then add to 13. Okay, so I'm writing down factors of negative 30. This is going to be a little more challenging because I have a mix of negative positive or positive negative. I don't know which way it's going to go. So I'm going down the line here. Negative 2 times 15 would be negative 30, and negative 2 plus 15 would equal 13. Now this is where the difference happens. Last time we just got to go x minus 2, x plus 15. But because I have a number out front, it's a little bit different this time. Okay, I'm going to split this plus 13x into plus 15x minus 2x. See how that still would equal, 15x minus 2x would still equal 13x. So I didn't change the value here of the expression. Okay, it's still going to be the same. Alright, so I rewrite it like that. Okay, and now I look at the first 2 terms only. What is common with the first 2 terms? I can divide them both by 3, and I can divide them both by x. So I factor out a 3x, and that will leave me with 2x plus 5. Okay, 6x squared divided by 3x is 2x. 15x divided by 3x is 5. Now I look at my back 2 terms. You might think, oh, there's nothing in common there. It's a 2 and a 5. Well, it's a negative 2 and a negative 5, so I could factor out a negative 1. And that would make that a positive 2x and a positive 5. Okay, this is your first time to check to make sure you're doing it right. If you're doing it right, the parentheses should match. That should let you know you're on the right path there. So now I take my numbers that are in the front of the parentheses, 3x minus 1. They go inside of parentheses, and then the 2x plus 5. And that is the factored form of 6x squared plus 13x minus 5. Okay? Look at this. This is the complete opposite of foiling. If I was foiling, I would go 3x times 2x, 3x times plus 5. That's what we have here. And then that's what we have here. Then I would do negative 1 times 2x, negative 1 times 5. That's what we have here and here. Then you would add the 2 middle ones. Boom. It's completely reversed. Okay, what happens if we had 4 terms? You're going to get some of these in your homework. We have just 4 terms. It looks pretty crazy. A lot of letters going on, a lot of big numbers. Alright? Step 1, always, what's in common? Okay, I can divide 6, 6, 6. Can't divide that one by 6. 2, 2, 2. Okay, I can divide them all by 2. So I pull that 2 out in the front. That makes my numbers a little bit smaller, a little bit easier to work with. Whenever we have 4, we go first 2, last 2. Okay, we just skip to that step, first 2, last 2. We factor out what's in common in the first 2. That's a 3x. And I'd be left with 3 minus 4y. What's common to the last 2? I could divide them both by 8z. And then I would have a 3 minus 4y. My 3 minus 4y matches both. That's good. So I have 3x and a positive, so plus 8z. And then on my other ones, 3 minus 4y. And don't forget your 2 from the very beginning. Okay, one special case to look at is difference of squares. It's another thing with 2 in it. So if I saw this, my first thing with 2 things is I'm thinking, what's in common? Okay, I can't factor out anything. There's nothing in common with x squared and a 25. But I do notice that it's 2 perfect squares. So that's why it's called difference of squares. Two perfect squares being subtracted. It's the square root of this one, x, and the square root of 25, 5. So it's x plus 5, x minus 5. Okay? Don't be scared if there's something else on that x squared. Square root of 16x squared would be 4x. Square root of 49 is 7. So I'm going to have 4x plus 7, 4x minus 7. There's another one that works out for perfect squares. Okay? This one's a little more difficult to see. And in fact, I think it's almost easier just to go about it the normal way. Okay? Normal way for 3 terms. Alright? But if you notice that if your middle number, if I can divide that by 2 and square it and it equals this, then you have a perfect square. So 6x, my coefficient there, my b value is 6. 6 divided by 3, or 6 divided by 2 is 3. 3 squared is 9. So that worked. So I can go x, and then it was a positive 3, so plus 3 parentheses squared. Okay, over here, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Okay, so it worked. So I would do an x and a minus 3. Alright, tough to kind of see those. It's almost, you're just going to be going through it and you're going to be doing it in your normal way for the 3 terms. And by the time you realize you had a perfect square, you'd be already done with it anyways. So it's just something nice. If you do see it, you can do it. If not, don't worry, you'll still get it right going about it the other way. Okay, today for homework, page 242, 20 to 34, and 71. Good luck.